What's up, guys? I hope you all are fine and good. So today I came here to discuss about the topic that is periodic table, periodic properties and variation of properties. It is a class 10 chapter and it is chemistry's first chapter, and I am reading from Selena publication. So today I want to discuss about some short questions and important questions about this chapter. So let's start. First, you all will be asked, what is periodicity? What is periodicity? It is the chapter 10. What is periodicity? Periodicity is the property that reappear at regular interval or in which there is a gradual change or variation at regular intervals. The phenomena is known as the periodicity of elements. It's very easy, like the properties that reappear like from 1 to 8 elements. After that, next 1 to 8 elements will be quite more or less same. Every period, every group, that every group from up to down, they are same, like same properties, they resemble same properties, like valencies are same. So this is known as, in short, periodicity. You may have to just remember the properties that reappear at regular interval or in which there is a gradual variation at regular interval. This phenomena is called periodicity. Now we will be asked that what is the cause of periodicity? The cause of periodicity is a recurrence of the similar electronic configuration, that is having the same number of electrons in the outermost orbit. You may have seen that reoccurrence of the similar electronic configuration. Electronic configuration means having the same number of electrons in the outermost orbit. The number of electron where the outermost orbit will be same, like in case of a period, from like this to this. In case of period, left to right, number of cells are similar. Their valencies get increased. First 1 to 14 they are increased, then it's gradually decrease. And if we consider group from top to bottom, then up to bottom the cell size or the shell number increases, but the valency remains same. This is the main cause of periodicity. Now next question. Write down the variation of numbers of shells and valency down in group and across the period. I am repeating again. Write the variation of numbers of cells and valencies down in group and across the period. So the answer will be down in group, the valency remains the same as I have told earlier, and across the period from left to right, valency decreases up to group 14, then increases to group 17. Now you may ask that why valency in a group remains same? So the valency in a group remains same because due to the similar electronic configuration, that is having the same number of electrons in the outermost orbit. Due to the same number of electrons configuration, that is having the same number of electrons in the outermost orbit. Like down a group, the same number of electrons are there in outermost orbit. That is in group 1, the valency is 1, so the electrons are also 1. Like in helium, from sodium, potassium, all the same. Now next, write some important periodic properties. Now comes your properties. So there are total 6 periodic properties, that are atomic size, metallic character, non-metallic character, ionization potential, electron affinity, and electronegativity. Now you may ask, define atomic size and nuclear charge. You all, I think, guys know it. What is atomic size? It is a distance between the center of the nucleus of an atom to its outermost shell. And what is nuclear charge? It is a positive charge present in the nucleus of an atom. Now, what is the positive charge? That are photons, which is equal to the number of photons in the nucleus. That is the atomic number, and number of photons is equals to the atomic number. Write down the variation. Next question. Now, write down the variation in atomic size down a group and across a period. What happened down a group? Down a group and atomic size. What happens? How atomic size varies down a group? Down a group, atomic size increases because the cell number increases, and across a period the atomic size decreases. Because due to the nuclear charge, because atomic number is increasing, as a result nuclear charge is also increasing, which attracts the atomic shells towards it. That is why atomic size decreasing across a period. Now, one of the important question: why cation is always smaller than the parent atom? Why cation is smaller than the parent atom? What is cation? When an atom loses electrons, it becomes positively charged ion. That positive charged ion is known as cation. So cations are, the reason is that cations are formed by losing one electron. That is, one electron become less, but the number of photons inside the nucleus is more than electron at that time. So when the number of electron will be less and the number of photon will be more, then number of photons and then the nuclear charge, that is the number of photons, will attract the electrons more strongly. As a result, they will contract and become smaller than the parent atom. This is the main reason why cation is always smaller than the parent atom. Like in case of Na, when loses one electron, it's become Na plus, which is smaller than Na atom. Na ion is smaller than Na atom. Now, one of the next important questions: why the atoms of inert gases are bigger than halogens of the same period? Why atoms of inert gases are bigger than halogens of the same period? I have told earlier that across the period the atomic size decreases, but here is an exception. Inert gas is at the last. So for this point of view, then inert gas must be, so in that point of view it must be smaller atom size than halogens, but it is not the case, because what is inert gas? Inert gas are the one, inert atom are the one, because inert atom, so inert gas have complete electronic configuration, that is they have their outermost shell full. We know that 2n is a rule, 2n square for first cell 2n, then 2n square, like this. Sorry, I mean 2n square is the rule. N is a number of shell. 2n square is the rule. First cell is 2, then 8, then 16, 32, like this, it goes on. So in case of inert gas, all the cells are full, so there is electron repulsion, that is number of photons repulse number of electron. As a result, inert gas are quite bigger. There is much inert force as two positive charge and negative charge repulse, so it's quite bigger than halogen atoms. Next question: anion is larger than the parent atom. Now, what is anion? When an atom gains electron, that time it's become negatively charged. That ion is known as anion. So the question is, why anion is bigger than the parent atom? So anion is formed by the gain in electron. As a result, the electrons are more than the protons. Therefore, the effective positive charge is less in the nucleus. It is obvious that the number of protons is less than number of electrons, so the effective attraction pull will be less. Therefore, the less inward pull, there is less inward pull, hence the size expand. Like in case of Cl, when Cl gains electron, it becomes Cl minus, which is bigger than Cl atom. Now, next question. Write the variation of metallic character down a group and across a period. What happens when we will move down a group? What will happen to the metallic character when we move down a group? Up to down. Metallic character will increase, and when we move from left to right, that is across a period, metallic character will decrease. It will vary in case of what will happen in non-metals. In non-metals, down a group it will decrease, and across a period non-metal will increase, because non-metals gain electron and across a period valence increases. Valency decreases. After group 14, valency decreases. As a result, the non-metallic character also increases. Metals are good dash agent. Metals are good reducing agent as they lose electron very fast. Write the variation of non-metallic as I told it earlier, so no need to tell this. Okay, in a period, size of an atom decreases from left to right. Explain why in a period, like left to right, why the size of an atom decreases. Why the size of an atom decreases? It is obvious that from left to right the atomic size will increase, that is the number of proton will increase, that is nuclear charge will increase, that is the more nuclear charge, the more inward pull. As a result, across a period, due to more inward pull, the size of the atom decreases. Now next question. Inert gases don't form ion. Explain why inert gas don't form ion. Because they have complete octet. That is, they have complete outermost shell. Therefore, they have zero valency. Their valency is zero. Therefore, they can't form ion. Thus not forming any ion. Now next question. How metallic character depends on atomic size and nuclear charge. How metallic character depends on atomic size and nuclear charge. We know that metals are good reducing agent, that is they lose electron from their shells. As I told earlier, on increasing atomic size, the shell increases. The nuclear pull decreases, therefore it's easier to lose electron. So metallic character increases in increasing order, in increasing in atomic size and vice versa. So on increasing nuclear charge, when we are increasing nuclear charge, that is from going left to right across a period, the atomic size will decrease because of much nuclear inward pull. Therefore it's hard to lose electron. So metallic character decreases in increasing in nuclear charge and vice versa. Metallic character dashes across a period from left to right. Metallic character decreases across the period from left to right. Now next question, it is one of the important questions. Define ionization energy or ionization potential with its SI unit. The energy required to remove an electron from a neutral isolated gaseous atom and convert it into a positively charged gaseous ion. is called ionization potential. Ionization potential is quite like forming cation. When an atom is in neutral state, the energy required to remove one electron from its outermost shell, that much energy is known as ionization energy or ionization potential, and is expressed in electron volt per atom, that is EV per atom. The SI unit of electron ionization potential is kilojoule per mole, kJ mole minus 1 or per mole. Okay, write down the variation of ionization energy across a period and down a group. Now across the period, ionization potential obviously increases, because across a period the atomic size increases. As a result, nuclear charge increases. As a result, nuclear pool increases, non-metallic character increases. Therefore, atoms are held more tightly closer, inward pull is much higher, so it will require much more energy to remove one electron from its outermost shell. As a result, across the period, ionization potential increases. Now down a group the shell number increases, that is the nuclear pool become quite less, and it cannot hold the atoms tightly. Therefore, it is more easier to remove one electron from their shell, and atomic size become large down a group. So, ionization potential decreases down a group. Dash have the highest ionization energy. Dash have the highest ionization energy. Fluorine. The answer is sorry, helium. The answer is helium. Helium have the highest ionization potential. If you imagine the position of helium, then it is in the rightmost corner. It is hydrogen, then helium. Helium is the rightmost corner, that is it is in the section of inert gases, and inert gases have complete octet. They do not form ion. It is very difficult to remove any electron from inert gases. So helium has the highest ionization potential. Write down the variation of electron affinity down a group and across a pair. Before it, I must say what is electron affinity. Electron affinity is the energy required to accept an electron to form a neutral isolated gaseous atom. It is quite like forming an ion, that is negatively charged. Cation is positively charged and it is negatively charged. The amount of energy required to bring one electron and to add one electron into an neutral isolated gaseous, to form a neutral isolated gaseous atom, it is called electron affinity. Then across the period from left to right, electron affinity increases, because it is same as ionization potential, but the difference is I am telling that across the period the atomic size decreases due to increase in nuclear charge and increasing atomic number. Therefore, the inward pull is highest. Therefore, nuclear charge is highest. So it is easier to attract electron because the nuclear charge is highest. Nuclear charge increases from left to right. Therefore, it's much more if we go from left to right. The photons will attract the electrons more strongly. And down a group, electron affinity decreases because the because the atomic size increases. As a result, it is not effective to hold more atoms firmly. Therefore, nuclear charge decreases and atoms are more it is very difficult to add electron down a group. Now, fluorine has dash electron affinity than chlorine. Fluorine has dash electron affinity than chlorine. The answer will be lower. Fluorine has lower electron affinity than chlorine. It is an exceptional case because you may imagine the position of fluorine. Fluorine is above chlorine. So I have told now only down a group electron affinity decreases. So chlorine must have low electron affinity than fluorine, but in this case fluorine has lower electron affinity than chlorine because fluorine is smaller in size. As a result, it has lower electron affinity than chlorine. So I have discussed around 22 or 21 questions. So I hope it will be helpful for you all. Thank you for today. Be safe and have a nice day. If you like it, please subscribe and share. Thank you.